I think he's going to, am I unmuted now? Yeah, sounds good. Good. Good morning, everybody. Appreciate y'all coming. I'm here because Sean asked me to come, and we've done some work together. I said it's probably a good idea because I would like to introduce everybody to what you probably already know, but I'd say in the last 8 to 10 or maybe 12 years, engineering has become a really big part of loss settlement. Originally, it wasn't. When I first started in disasters in 1990, we were just contractors, and we'd go out and meet adjusters, and we'd walk around and look at the loss and figure it out and go rebuild the thing and get people back in business. But that's not the way it works these days. So I've got all the credentials a person needs, but I'm actually just an old iron worker that kind of went to school and got some what I call club memberships. But you need those club memberships to have credibility, especially for attorneys. They like that. Looking at what you do, what is the goals of structural engineering and design? And what I'm talking about is new buildings. You've got to preserve life safety and protect property. That's the most important thing. You don't want to hurt anybody. It's a lot of predicting how structures will behave, how they'll react to loading, and that's during construction and after construction. Predict how structures will fail and why, and predict the reactions to wind, heat, earthquakes, expansive soils, you name it, lots of things. Safety factors are required and should not be consumed. You'll see that in a little while. It's kind of an important issue. Now, in disaster recovery engineering analysis, the goals are just a little bit different. Well, a lot of them are the same. We still don't want to hurt anybody. And usually when we show up, something is messed up. Something's falling down, something's burned, something's broken, something's crashed. It's a problem. We've got to be careful. Safety is a big issue. We got to have a demolition safety protocol. In other words, we can't just go start knocking stuff down, especially if some things are good. What can we save? What can we do to mitigate this loss without causing extra damage? And we've got to document the loss. That's probably the most important thing out of that. Disaster recovery engineering goals. What's the cause? What's the cause of this damage? And causation within a reasonable degree of engineering certainty. And that, to me, as I've learned after sitting in federal court for a while, that's really, really important. Building envelope failure analysis and structural failure mode analysis. You've got to understand what the modes of failure are so that you can understand what is broken that you can't see. You have to understand the current building codes and what's required to upgrade. Redesign for rapid recovery and compliance. There's always an element of design, whether it's shoring design, stabilization design, or redesign with different materials. And in some cases, we've redesigned complete different building systems to make it be rebuilt faster. Expedited inspections. The city, they work, from 9 to 5 or 8 to 2 or whatever it is, but you can always pay them overtime to get those inspections up sooner. And if you get the inspections in little discrete packages, you don't have to wait until you have an entire permit package to go to the city to get reviewed and approved, and sometime further down the line, you're going to be able to go build. Now you take little pieces and little parts, like I need a demolition permit, I need a concrete permit, a steel permit, maybe an exterior building envelope permit. Looking at structural integrity is really an important issue. What is it? Well, you just have to ask these questions. And if you ask these questions, and it's funny, you see, can it withstand hurricanes and can it withstand earthquakes? Well, if you're building a building in Hong Kong, it has to withstand both of them because they can get earthquakes while hurricanes are going on, and it's actually happened. Can integrity be restored, or is it a total loss? That's a pretty important question. Now, the code, look at the IBC, International Building Code 2018. This is how they define substantial damage. You always go to the code if there's a question. Here is the International Existing Building Code. That's another IBC, but it's the existing building. And they define it in 3 different conditions. Condition 1, and you can read all that there. I don't have to read it for you. Condition 2, and this again requires some structural analysis to understand what's damaged and how much of it's damaged. And if you meet any of these criteria, then you go to the next step. And then there's condition 3. This has a lot to do with snow loading, what can happen to loads that occurred that are different than normal. So you do these calculations to understand where that fits in the realm of the code requirements. Now, I would call this a time-related structural failure. And you know how you get the adjuster that comes out and is Oh, it's an old building. Oh, there's alligatoring in the roof here. Doesn't mean it was leaking, but they always point to something old. So I'd like to throw this one in here to get people thinking about how long a building should last. And just because it's old, does that mean it's really old and it's deteriorated and it's no good and they should have never insured it? Well, they already insured it. Earthquake. This was Loma Prieta in 1989. And I say 1 minute seems solid and safe, but the next minute it doesn't. Well, when you see this floor coming at you in 3-foot waves and everything's shaking, because I was in that Loma Prieta earthquake when I was at Stanford, and it was pretty amazing. Because when it started shaking, it's like run out of the building as quick as possible and stand back and watch a 6-story building jumping up and down about 3 feet and shaking back and forth about 3 feet. It ruins your whole concept of what's stable. This is a shipyard in Seattle. Most of this was vertical movement, not a lot of lateral movement. Even though the ground had lateral waves, most of it was vertical because it was related to water and port facilities. Of course, everybody knows about the bridge in Minnesota. These are the types of failures you could have. This is an overloading failure, and the reason being because this little piece of metal failed. Well, they had a lot of construction equipment on there, they had all that traffic, and then this piece failed because there was so much bird droppings that the inspectors missed the crack in this piece of metal, and then it fell down. So it's not a good place to be. Collapse condition defined by the court. Now, I don't know if this still applies. Are there still lawyers here today? There was a bunch. This was several years ago when we worked on a collapse condition, and this at that time was how collapse was defined. And I was involved in this situation where a condominium here in Houston, it was terrible. It was rotted. I mean, look at this 2x4. You could crush it and it would turn to dust. Took 32 samples. Every one of them was like this. Basically, the sheetrock and the stucco were holding the buildings up. This is a stairwell wall, and as you can see, what you're looking at is the outside wall from the inside, and you can see it's sheetrock or gypsum wallboard on the outside, and they had one layer of craft paper and then stucco. And if you don't know it by now, stucco is not the best material for Houston because of the rain. Well, this was a collapse condition. This stairwell had to be shored up. And we had other issues too. When I went out there and I looked at this beam, I said, this beam looks pretty marginal to me, quite rusty, and we need to do a little bit of demolition to see what really the real condition is. And when we did that, you'll notice that wrong one. There we go. You'll notice that the bottom flange here has been completely released from the beam. Now here we have precast planks, and above that is 3 stories of condos. That wouldn't make you feel real safe, would it? So in the end, we made a claim, the lawyers did their thing, and we got a settlement, and the people tore it down and left and got their money. This was definitely a collapse condition, imminent collapse, or as they say, if an engineer determines it needs to be shored up, and this was a parking garage, you can see the car, there I go again, wrong one. Laser, here we go. There's the cars parked under there. Well, we had to shore this whole thing up because obviously the beam is no good. So that's a different type of collapse. Now here's what I call an actual collapse condition, not an imminent collapse. Tornado hit, knocked the building down, no question. Total destruction, scrape it, replace it, keep the slab. Slab was okay. Now here's where I say structural damage question mark. And the reason there's a question mark, and we'll show you that pretty soon, but you can see we've got windows blown out, doors blown out, part of the roof blown off, and this is one of 2 hangars at this location. This is in Nashville. That got hit by this tornado. And the reason that I ask about structural damage is you'll see that in the next slide. Hangar doors were blown in, roof was blown off, these airplanes were knocked all around, and I'm going to hit the right button. You see down here all this gasoline, this avgas back here, all that went into the office areas. So when I hit the site, we had a bunch of pink insulation blowing all over the place, and people were actually running around trying to catch this insulation before it went out onto the runway. Because Southwest Air didn't really like insulation in their engines. Can't blame them. So I decided, I told the people, stop, quit chasing this. Get some hoses and hose all this stuff down so it won't blow around. What an idea, it worked fine. Now this is really not a sardine can, even though it kind of looks like it. But the question is there structural damage? Well, in this case, no. And when you look at this structure, this is an old riveted structure. All these are rivets. All right, this thing was built by the WPA in the 30s. So this was very important because the adjuster rolls in and says, oh, this is total constructive loss. And for some reason, this one of 18 locations was an ACV, not RCV. All the rest were RCV. So this adjuster was like, total constructive loss. Here's $500,000, goodbye. And well, we lost imaginations. We found out that the broker made a mistake. We got it turned back to RCV. And then we proved that there was no structural damage. And there wasn't. All the skin and stuff blew off, the doors, the windows, everything, but the structure was fine. And so because it was an old building, it was even better than this building here that was brand new. They had turned the keys over to the owner the day before, and then the tornado hit that night. And that's a brand new building. Well, it's a lot less strength, a lot less stability in this building than in the 1930s building. Back to our old buildings again. Because at the time that it was ACV, they would have only gotten $500,000 if it was a total constructive loss, and we ended up getting $5.4 million to rebuild the whole facility. That's why. We didn't want them just to say, go away. And the way we did that, we got a local appraiser there in Nashville, a property appraiser, to evaluate the slab, evaluate the structure, provide a value on it, and with him and with me proving there was no damage, that's how it ended up. It came out great. Deep gouges in the pavement. These planes were drug all around during the storm, and of course the adjuster was like, oh, that's just normal wear and tear, no big deal, just flood coat it, you'll be fine. Well, no, not true. The office areas are these little side buildings, and they weren't separated properly from the hangars. You have to have a 2-hour fire rating from aircraft storage areas or aircraft with fuel, because some hangars are designed for aircraft with no fuel, but these had fuel, and they were being worked on. So you had to have that 2-hour separation. So that became part of the code upgrade. And this one's just for fun. This door is a 1/4-inch steel plate. And I'm glad I wasn't there when all this stuff was blowing around and caused all this crazy damage. They were done in 5 months, ended up just right. Everybody was happy. And I have to get some water. Excuse me. I'm sorry? I'm going to have to come closer. I'm sorry. Yes. Yes, we had some tanks, too, that we found because the electrical system ran through the first hangar, which, of course, was destroyed, and it fed the second hangar. And the best way to get the electrical system back over was underground. And when we went underground, we found some tanks and had to get them out. But it was all covered because it was an expedited reconstruction model. Now here is a residential deal, fire, 24 units, and there was a lot of previous hurricane damage that wasn't repaired correctly. It was basically hidden behind the sheetrock. It destroyed the top floor completely. Of course, we had fire water damage throughout. And there was a ton of rot. More rot in this building than any other building. And what's weird is the city hydrants didn't work, so they had to use a fireboat to put the fire out, and that's salt water. And you can imagine the corrosion. Every nail, every truss plate, everything was rusted and corroded with that white powder. It was terrible. So we had to go out there and hand brush everything and paint everything with Rust-Oleum that was going to stay in place. Now, this top floor was pretty important because it provided stability to these what are called wing walls. And these wing walls held up these balconies. And you can see the balconies are in the middle. And when these wing walls deflect left or right, boom, down come the balconies. Well, as it turns out, the balconies were actually resting on 2x4s that were nailed to these wing walls. So you had, 1.5 inches on each side holding up real live concrete balconies, which was crazy. And then the second these walls went a little bit, down came the balconies. Well, we can't rebuild it that way. So it became kind of an issue, but I went through the thing with the adjuster. And then as we found, look at this. This doesn't look real healthy from a building standpoint. That concrete has punched through and it's down here, and this is how it was when we removed the fascia off of this walkway. It's about a 2-foot deep egress walkway. This was everywhere. This place was bad. I mean, that's a serious problem that has nothing to do with the fire. But in the lawsuit that ensued afterwards, it got paid for because this wouldn't have been exposed, this would not have been an issue, and the loads wouldn't have shifted had the fire not occurred. So part of the engineer analysis was to get them to understand that, and they did. Let's see here. Oh, this is an interesting fire in Chicago where the asbestos abatement pump or the negative air machine caught on fire at night, and it burned this beam. See how white it is? I've always been told white smoke's the hottest, black smoke is cold. Well, this beam deflected about 2 inches, and it was tied into the concrete slab above. And so it's like, okay, what do we do? Well, we have to get the beam cut loose above and then cut a hole in the building in the side and drag the beam out of the building and then put a new one back in. And it was real obvious because all we did is run a laser line on that beam and show how it was deflected. And then we did some material tests to show that its strength was reduced significantly, got a new beam. Here's an ammonia explosion. This is in El Paso, a refrigeration and distribution center. The ammonia exploded, but it didn't create a fire, which was good, but it sure knocked this building around. I mean, this was almost a total destructive thing. It was in bad shape. In fact, it blew holes in the roof. Can you imagine being in this building when this happened? And all this air conditioning, refrigeration equipment, more ammonia coming out. We had to get rid of all that ammonia, evacuate that. We had to get all kinds of stuff taken care of before we could actually go back and try to demo this and rebuild it. And that's what happened eventually, although I was not the one rebuilding it. Somebody else did. Now here's a case of a builder's risk collapse or loss. They were putting this truss up. It's about 200 feet long, and they had 2 cranes on it. 2 cranes is not like having a co-pilot. And what happened was one crane started tilting, and once it goes, the other one went, and the whole thing came down. And what a mess. It twisted everything up, and it was really bad. And they called me and said, what happened? Well, the first thing I see is, what are these cranes sitting on? Gravel. And this is at Texas A&M. It's a special events center, and it's kind of underground. So it was all wet. And I'm walking around on this gravel thinking, this doesn't look very solid. So I said, look, scrape this gravel, pump this water out, put some oil field timbers in here, and bring a bigger crane. So that's what they did. We brought a bigger crane, 1 crane, not 2, put the new truss in place, and it was all repaired eventually. Here's another one. Is this a defect or is it a covered peril? That's the question. The condominium association called, said all our bricks are falling off of this building. And it was 4 stories of bricks landed on these separate footings that were on the backfill because the parking garage is underground. So already we have an issue. Well, they thought maybe it's a leaking sewer line or a storm drain or something like that, and we can make an insurance claim. So sure, let's check. No leaks. And then I started doing some calculations, and we determined that the footings upon which all this rested were not big enough. And the backfill wasn't backfilled properly in 6 to 8 inch lifts, so it was really loose. So one day, I guess probably after a big rainstorm, here comes this. The bricks are starting to come down. We get a call, oh my gosh, it's a panic. And it's really a design defect. And this is just part of the same collapse, because this vertical portion of these blocks here were the ones that were on the footing down here that failed. So all around the building, these were failing. And then we also discovered that the beams that go from here over to the next one over were way overspanned, and they were sagging, and that was causing additional forces on the bricks and causing additional problems. Now, this was an interesting one, another tornado. Seems like we always get into tornadoes, too. Twisted metal. Now, when you think about the forces that are in a damaged structure like this, it's really kind of amazing. It's like if you have a tree that fell and it's leaning on something and you just cut it and it twing, pops up. Well, if you got a bent metal that's got a lot of stored force, you can't just start taking it apart. And this is in Montana, a real remote location out in the middle of nowhere, because this is a coal loading facility and nobody wants to see coal, right? So it's for power plants. But just because it was in Montana didn't make it a real bad and scary situation. It's where its location is where it was kind of difficult to deal with. So that green material you just saw is up on a 100-foot tall coal silo. So we had to really think hard about taking this thing apart and making it work. Now we're going to switch to a more boring topic, the roofs. And roofs are pretty darn important, as we all know, because that's where most of the controversy lies. Types of roofs: standing seam, exposed fasteners, R-panels, whatever you want to call them. The types of flange or the types of connections that we have, there's many of them. And this summarizes some of them. But what this does is creates a situation where if you have one damaged panel, it really isn't simple just to take one out, because it's connected to the next one, it's connected to the next one, and the next, and the next. So if you have 4 or 5 damaged panels, maybe 20 panels away from the end, the scope should include all those 20 panels plus these 4 damaged panels, because you have to take them off in the order in which they were put in. So it's not a simple thing, but you can convince people of the case. The snap locks, they look great, they work pretty well, but once you take them apart again, they don't work as well. In fact, they don't work at all. You have to put a new piece in. These seams, the mechanical seams, either single or double, nothing can be done to these. You don't unbend them and bend them back. They're gone. If you have a damaged panel in the middle, you cannot deal with this. You just have to take off the whole roof. Metal roof damage. Oh, I love this one. I read a letter from one of these engineers. Generally, when damaged, the metal panels would be characterized by torn or missing panels. Wind pressures acting on the panels with sufficient strength can lift and subsequently fold, tear, and or remove the panels. Remember that fold, spindle, mutilate thing, right? Well, that's his definition of damage. So if they aren't completely torn off or folded or torn or whatever, there's no damage. And I say that what he's describing is catastrophic failure, but it ignores actual damage. And now look at what Haig says about metal buildings. And we all know Haig, we all know Nelson, Donan, all the same guys show up, right? It's always been a battle. And now that I'm in a room with people that kind of fight the same battles, it feels good, because sometimes I feel like I'm doing it all by myself. Well, their definition is right there. Reduction of water shedding capability. It's kind of like yesterday when the attorney was saying, oh, no wind-created openings, right? How many times have you heard that? Reduction of expected long-term service life. Oh, long-term. Well, how about including this stuff? Scratches, corrosion. I mean, when I used to build metal buildings, which my first job out of high school was building metal buildings, a 2-acre roof in Waxahachie, Texas, if you did not sweep the roof every night of the little shavings from the screw holes that you drilled, that would rust overnight. If you had a scratch and left it, it would rust overnight. So you can't just say, oh, it's a scratch, it's a dent, it's no big deal, it's cosmetic. No, that is deterioration, it's accelerated deterioration. And a lot of things people miss are those closure strips at the ends, usually at the bottom or at the top or both, and they're blown out. They ignore strip screws like that's, well, no big deal, right? Well, that's where water comes in. And the wet insulation is, I think, the most often ignored. And it just makes me mad sometimes. But thinking about this is obvious, right? I mean, it's rolled up, it's off, and nobody's going to argue. It's obvious. But now, and here's some obvious damage, although the adjuster on this one tried to claim it was a design defect. But then I showed him that this metal building manufacturing company standard detail was this way, and it's been designed by engineers, so it's not a defect, and he finally agreed. And here's some obvious damage. Yeah, the roof's blown off, the metal's bent, and this is over a refueling facility, lots of tanks of gasoline, so it's kind of you don't want to be dropping stuff, and causing trouble. But now look at what I call actual, not obvious, but actual damage. When you lay an R-panel metal roof, all the manufacturers say the laps shall be away from the prevailing wind. And there's more than one reason for that. So if you get a hurricane that comes against your laps, they can easily tear out what we call lap screws or stitch screws that hold the laps together. It's very thin metal. A lot of times people strip those when they're installing them. I know, I put in tens of thousands of those screws. Oh, sorry, go back. Yeah, here's a typical lap screw that was stripped. And this is where an owner tried to coat, and you can see the coating on here, that kind of latex-looking stuff or whatever, coating, to try to stop the leaks. And then they tried to put in some screws. That's a new screw. It's not been coated. But the hole was so stripped out that it didn't work. and this one hasn't been resolved yet, but we're still working on it. But I say you go inside and look for leaks, okay? Go find the leaks. Now, in metal buildings, you can have a leak at the peak, and the water comes in, and if you have the blanket insulation under, it soaks into the insulation and eventually works its way downhill. So you may have insulation down near the eave that's absolutely soaking wet, but that leak probably came from somewhere up above. Here's an outdoor walkway. Hey, it's not a leak issue, but somebody's going to try to say, oh, that's footfall. I mean, how many times do you hear that, footfall? You know, it's like, did it fall? Well, kinks, what we call kinks. And in the metal building business, you can kink a roof simply by walking on it. That's a kink, okay? You can do that. But as you see right here, we have a lot of edges that were smashed and dented right here. So it's flying debris. I could easily say, I know what a kink is. I know how they happen. This is not a kink. This is flying debris. Here's an obvious one. Whoop, went fast. Another one where flying debris, you can see the scratches that opened it up. And it's an R panel, so you can actually take that panel out or 3 or 4 panels out and repair them or replace them with new panels. Not a problem. But, you know, this is damage. It doesn't require an engineer. Now, here's damage that somebody would say, oh, it's no big deal. It's cosmetic, whatever. Well, my position has always been if you have dents, scratches, anything like that, it's damage, period. And that's not what they had before the storm, or in this case, a hurricane. These are roofs we're working on right now in South Texas with these schools. All these schools, it's amazing. 15 million square feet of schools, and almost all of them are metal roofs. But this is damage. And you look for these things. You got to get on the roof. And, you know, you can walk on this roof and think, wow, this is only a few little dents. How can I justify replacing this roof? But it seems so loose and spongy, and it's just not normal. Go over to the other side of the peak, and oh, this one's solid. And it's not bent, and it's not dented, and it doesn't feel bouncy. Well, then the side that the wind hit is damaged. Look for leaks. In this case, you notice we got water leaking out of the insulation. Well, when I saw that big bag of insulation, I knew what it was. Poke a hole in it, here comes your water. I mean, and it's obvious that this insulation is also wet too. It's falling down. Well, follow the leaks. That's what you have to do, follow the leaks. I mean, they try to get away with this. Well, you can just tape some more insulation up there. And in typical rigid frame structures, insulation is either running from eave over the peak to the other eave, and the sheets are on top of that, or they run the insulation longitudinally along the length of the building with bands, and then the sheets go on top of that. Well, if they're running the length of it, and you get a big wet section over here, is it justifiable to take all that out? Or do you just cut the insulation here? No, you don't just cut it, because now you've got a thermal gap. You've got a metal roof, you've got a thermal gap, you've got a bad energy efficiency situation. So my position has always been, if my insulation is damaged in a pretty sizable area, the whole thing has to go. Enclosures. People ignore this like it's nothing. Well, this is, believe it or not, one of the most important elements, because if you have an insulated roof, the insulation is in there right uphill of this closure strip. If you don't have insulation in there, now you have every one of these ribs, what they call elevated or raised ribs, is a conduit for air to blow in. So you've got to go unscrew the bottom row of screws at the very least to get the sheets up to put those back in. And in some cases, people put tape mastic on those closure strips. I know, I've put in many thousands of feet of these closure strips. They put that plastic mastic tape on there. Then you're in a position of having to clean that old glue off the bottom of the sheet and on the eave girt to try to put a new piece in. And depending upon how old it is, you may not be able to clean that. And it's a gut call, but when I look at it and I see it can't be cleaned, and these are a short run roof, I say just replace the whole roof. That would be our position. Oh boy, I went too fast. Oh yeah, here's one where the closures blew out and the insulation was bagged because of wind, not because of water in this case. But I know that the insulation is laid over the eave girt and then turned back, and then the sheets are put on top of that to hold it in. Now, if you get that wind in there and it blows it down, it's pulled it out from under the sheet. So at a minimum, you've got to pick the sheet up, put it back, and then put the sheet back down at a minimum. Usually it's more extensive than that. this is just for grins here, who would depend on this beam? You know, this is one of those, oh, something happened, but we don't know what really happened. Well, we got to figure it out, so we do, and nobody wants to do that. Nobody wants to depend on that. Conclusions. Structural damage can be obvious or require extensive analysis and evaluation to determine the actual condition. And this goes for wood frame structures too. We recently helped settle a claim where a slab lifting company was supposed to lift the whole slab, but they only lifted part of it, and it was an extension or an addition, and it broke the slab. And I was there when it happened. Crack, I hear this bad crack, and this whole side of the house, and the roof was wrinkled and everything. And it was like, well, you got damage here. Oh, no, it's fine. It went back. You know, the adjuster's like, no. And so we pulled off the sheetrock and show all the broken studs. And it finally convinced him. Structural damage includes covered perils, design defects, construction defects, material failures. You've got to be able to sort that out because you don't want somebody later nailing you and say, aha, that was a failure, or it was an ongoing lawsuit about a construction defect. And we have one of those in the schools down in McAllen. One is under a construction defect lawsuit, so we're staying away from that until they resolve that. It's often obvious and easy to quantify, and sometimes it's not. Damage to metal roofs is often not obvious. And that's the hardest part. You've got to find the leak, trace the leak, find what damage there is within a reasonable degree of engineering certainty, and then make your decision. Finding the leaks usually leads to roof damage. Metal roofs can absorb abuse. Yeah, it can absorb lots of abuse and still be there, but it doesn't mean that it's a good roof or that roof hasn't reduced its life, or the damage hasn't reduced its life. Closure strips, which are ignored, they're really important. Engineering analysis must be utilized to find the truth. It's real simple. The truth is required, okay? I mean, you can't stretch. And I was told by an attorney one time, you don't go into court with 99.999% because they're going to nail you on that .001. Absolutely right. Some engineers practice to serve the interests of their customers and their business plan to serve those customers, and that kind of sway them. I mean, I've actually recently had one of the big three engineers argue that roof tile, clay tile, was not damaged by hail. And as his example, he used the Hague article, I think it was called Hail Damage to Tile Roofs, and said, oh yeah, this is the standard, blah, blah, blah. Well, and he said, oh, it's thermal constraint, therefore they broke, it's not hail, and all these lame excuses. Well, I pointed out that when I looked at the Hague article, it was all about concrete tile. And there were only 3 tests on clay tile, and they were a different configuration. And on this one roof, they were held on with 1 nail. So there is no thermal constraint. And then he even argued that my drone footage was taken from elevations of 8 to 10 feet and weren't as reliable as his pictures because he was walking on the roof. Well, if you're walking on the roof taking pictures, how far away is that picture, right? And our drone was the same as theirs, has that Hasselblad camera with a 1-inch CMOS, and it's 48 megapixels. So it was a lame argument, but he actually argued that he wouldn't change his position. And it's like, come on, man. It's so obvious. And he actually had in his report a lot of dents and stuff on the gutters and elsewhere. It was pretty amazing. A whole bunch of references which you don't have to worry about. And if anybody wants a PDF, just let this young man over here know, Keanu, and he'll have one emailed to you. Any questions?
Do we have questions?
Was it that boring? Yeah, I'm still licensed contractor in California, an engineering contractor. I'm not a licensed engineer, but we have a bunch of guys out there that we know that we can collaborate with because I've done a bunch of work out there. Well, see, it's the old iron worker in me. Common sense, right? Am I going to fall or not, right? Is it right or wrong?
What's your question?
There you go.
I understand how to do a slab.
Yeah.
Liberty Mutual did my foundation for 10 years. Engineers tell me, you don't even have a college degree. Dude.
Get over it. Right? Get over yourself.
My professor wrote this business out there, go do it. I did.
Good. Well, you need some help, let him know, and we'll get
We have a question from the crowd. What is cosmetic damage?
Well, you don't want me to tell you what I really think.
Please.
A pretty lame way of saying we don't want to pay. I mean, yes, there are a definition of cosmetic, but to me, you know, I guess into the lawyers and insurance, okay? To me, what is damage is the question. Call it cosmetic if you want to. And you see it happen all the time. Oh, it's just cosmetic. Oh, no, it's not. It's a dent. It's a stress. That metal is no longer capable of the load-carrying capability it used to have. So I really don't think much in terms of cosmetic damage. If it's damaged, it's damage, period. And I will stand on that. And if somebody says, well, we have an exclusion in our policy, that's for the lawyers to argue, not me. I'm going to call it damage.
Thank you.
Anything else? That's it? Yes. Did I answer the right question? Oh, that one has not been settled yet, no. He didn't change it. I'm going to do a response with the high resolution camera, and I'm going to show A squared plus B squared equals C squared. You standing on the roof, you're taking at least 7 to 8 feet away. Get over it, you know. We'll get there.
Mike.
Yes.
When you were talking about replacing a few panels a while ago, does the policy ever come into consideration? It's Cal back here by Sean. Does the policy ever come into consideration when you're making determination? Do you think about policy language, or do you just make it based upon an engineering perspective?
No, absolutely. We have a guy working for us for the last several years who used to be a public adjuster. And so his thing is, give me the policy right away. We're going to read the policy, know what it covers, what it excludes, that sort of thing. So yes, we blend that together.
Okay, so if we look at a roof that has 3 panels replaced in the middle of it, do you believe that that's bringing it back to pre-loss condition?
Usually not.
Excellent answer. Thank you, sir.
At a minimum.
Thank you. Mike will be around, so I'm sure if you have more questions for him, which I'm sure we all do, we can find them and ask him at a later time.